Hi, so this is our Excavator app, the app that we programmed using Tethys. We're going to go ahead and give you a short demo of how we did that and how it works. And my name is Seth.
My name's Brandon.
And Kyler.
So the problem that we wanted to address was when a construction site requires excavation that's below the water table, water starts to seep into the excavation site, and this can pose a lot of problems such as flooding, boiling, heaving. If the contractors and the owner don't take those into account, it can pose a lot of risks to the workers as well as a lot of financial costs. So we created an app that allows the users to estimate that infiltration so that they know what the inflow is, so they can know how much they need to pump out, so that they can be working in dry conditions. And then having this estimated flow will kind of give them a rough estimate of what they need to do.
So Kyler here is going to give us a short introduction to our app.
So it's pretty bare bones. We wanted it to be more extensive than it is. Unfortunately, the programming and ArcGIS weren't very compatible. But basically, when you're modeling well equations, you have two situations: either it's confined or unconfined, and these buttons allow you to select which one. So then the proper script will allow you to run and generate the proper calculations. In this case, we'll demonstrate both. And then each of these boxes allow you to calculate a pumping rate. You can calculate the hydraulic conductivity of the soil, and you can also find the cone of depression height. And the cone of depression is just this right here, where the well draws down the water table, thus creating this cone. So, for example, for calculate pumping, you can select if you already know the hydraulic conductivity, the aquifer thickness, the radius of the well you're installing, and then the original water table height, and then the height that you want to bring the water table down in the well. You calculate it. It gives you a pumping rate. It gives you the area that the well will affect, and it also provides the radius of influence, which is the max radius that the well will draw down the water. And then, of course, it's the same for all of these, really. You just need to directly input the variables that you require. And then it just spits out what you need. So in this geoprocessing service right here, it just simply allows you to map out a footprint of your construction site. And it gives you the area in square feet and the perimeter length. So then you can use the area here to somewhat estimate how many wells you might need to sufficiently drain your project site. And as I kind of showed before, if you need a refresher or want to know exactly which parameters you need or what they're referencing to, you can just click on the diagram and it pulls up this PDF, which pulls up these separate diagrams for confined, hydraulic conductivity, and unconfined situations.
Yeah, so we're going to go ahead and talk through some of the stuff that's going on behind the scenes. Here we have some of the JavaScript code. This is a script that runs after you plug in some of those variables that were shown earlier. When you type the numbers into the boxes, those are assigned to some of these variables. And if you look on the right side, where like X is the flow in this case that the pump will give. It's that is the equation for either confined or for unconfined, and all of that is run behind the scenes using the equations that are generally used for this type of calculation. And this was one thing we wanted to highlight that we learned in this project. This is jQuery, which is kind of an abbreviated form of JavaScript language, and there in our app this allowed us to do some interesting things with the menus.
Basically, this just showcases that you're able to show or hide. Like, this just provides the animation for the menus. It's basically it. I just threw it in because I thought it was really cool.
Yeah, so you can look back earlier in the video and see when we click on any of the equation buttons that everything kind of scrolls out, like the instructions. They don't just appear immediately, and that's because of this jQuery code where you can specify a time length that it will take to open it up, and it kind of helps you keep track of where things are coming from. Yeah, we also have this data geoprocessing service included. The area and length are calculated using one of Esri's data services, and you can see on the top there that link to their server and geometry server. That's where you can make calculations on the map like length and area. So that's how we incorporated that into our project. And we feel like this does help solve the problem that contractors and owners have, because you can easily visualize the job site from wherever you are, and it gives you a quick way to estimate what the infiltration might look like. And you could have a guess of how many wells or how strong of a well you would need to lower the water at your job site. Thank you. Please check it out at GitHub link.